Hi everyone, and welcome to this video lecture on Rhino. Now we are looking at solids. So we're getting to the excited and pointy end of Rhino. At this point we understand the basics of the interface, we understand curves, how they work, how that then translates into surfaces. And now we're going to be looking at what that means in terms of solids. And this really is the fun part because solids is what we directly translate to things like our 3D printer, our CNC milling lathing machine, our laser cutting tools. This is exactly where we're going to start to take our products and turn them into surfaces in real life at 1:1. So this is where the crux of it all comes together for your assignments. Now, of course, you have to understand the curves and the solids tools, the surfaces tools before you can manipulate your solids. So now we are ready to start that conversation. So let's get stuck in. First thing to understand about solids is that nothing is actually solid in Rhino. Once again, like the whole curves, even though it's a straight line, it is a trick we play again. So Rhino is not ever making anything completely solid. It is just an infinite surface that is wrapping over and back onto itself again and again mathematically. So it's infinitely thin and infinitely hollow. It's not a true solid. Which is good for us because that's what makes Rhino so powerful, because it simplifies objects down for us. We don't need to use any data that we're not using or any computing power that we're not using. So let's take a look at what that might mean a little more simply. So we have some basic geometries, basic solids we can find up here. These are our primitives, things like our box. We can make a box very simply. Little cube like we've got there, we've got a sphere, we've got a cone. These are our simple solids, our primitives. From there we've got what we call a polysurface solid, which is like this one we can see over the corner here. Kind of looks a bit like a Star Wars shape or something that Herzog de Meuron might design, this guy over the back here. But where it's come from is, as you might have guessed, a bunch of curves that we've drawn together here that we have, which we then turn into planar surfaces and we've joined together, which we'll look at a bit later. So while Rhino now understands this to be a solid because we've joined it all together, we know that it really isn't a solid. If we were to explode this and then pull apart any one of the faces, we'd be able to see inside it, and we can see what Rhino sees all the time. So it's never actually solid, it is hollow on the inside, which is important to understand as we get into our 3D printing later and we start working out what actually happens on the inside of the object when we're trying to create three-dimensional shapes. The final solid type is one that we've seen a few times now, is our extrusion solid. So to make this one, extrude our curve that we've created, we've got solid turned on over here, and we set the height, and that effectively forms an extruded solid. So our primitives, polysurface solid and extruded solid, are our three types there. Okay, so let's start playing around with some of our solids. I'm going to delete a couple of these just to make it easier to see what I'm doing, and we're going to start to manipulate this sphere. If you want to make your own sphere so that you can play along, just go up into solid, sphere, and you can do a center radius or a 2-point, whatever you want to do. I'm just going to arbitrarily make a sphere for now. All right, so first thing we're going to do is jump over into a different view plane. I'm going to choose the front view, and what we're going to do is a trim command. So we type in trim, and then we're going to click line here, and we're just going to draw a line that goes across and make sure it intersects over both sides. Then it's going to ask us, what are we going to trim? I'm going to trim the underside of my sphere here, so that's now trimmed off. Press enter to finish, and I'll jump back over to our perspective to see what's going on. Now we go underneath here and we can see that we now have very much a hollow sphere. If we jump over to our details section, we can see that it's a valid surface, it's a trimmed surface, but it's also open. So what we need to do to remake this a solid is to cover up this gap, to put a cap over it. We know from our surfaces video, there's a few ways to go about this, but because this is just a flat trimmed plane, we can go ahead and just make a planar curved surface. Click on that curve, press enter, and that's capped it off nicely. If we then grab everything, type in join, hit enter, we'll see two surfaces or polysurface joined into one closed polysurface. So that closed is the key word that we want to know here, and that's going to come up a lot of times because it's important that always we're dealing with closed surfaces, aka solids, when we go to our 3D printer later. The 3D printer won't understand where it's in and out if things start opening up. So you always have to be dealing with closed polys, closed surfaces, or solids. And we'll get into more ways to figure that out coming up shortly. All right, let's say we want to make a little bit more of a freeform or organic slice into our sphere that we have here. So much like we did with our surface command, we're going to think very carefully about what view frame we're in when we're doing our trim. So I've put it onto the front view now, and I'm going to make a freeform curve, control point curve, starting outside my sphere rather than on it. And I'm going to do some interesting shape like this. There we go, to finish. And then we want to do a trim command again. Cutting object is going to be my freeform curve, enter. Object to trim is this top side of my sphere, and I click off. And again, remember, viewpoint matters here. So we're on the front view, so we can see that the trim has gone directly through that sphere. Let's take a look at what that looks like in our perspective. And we can see that it's pushed effectively the whole way through this sphere here, but only in that one plane, like that. So that creates now quite an interesting object. We're back to having an open surface, so we need to think about how we're going to make this a solid. So a really good tool to use in this instance, and you'll see happening quite a lot, particularly if we're dealing with geometries like this that we might turn into a vase or a vessel or flask or something where this repeats back on itself, is the offset command. And the offset for solids works very much the same as offset for surfaces. After all, our solids are made up of surfaces in Rhino. So we jump down to offset surface. Remember, these white arrows are our normals. So that's telling us in which direction we're going to be offsetting. That's incorrect at the moment. We want to go inside. So I'm going to come down to here and click flip all. I can now see that that's pointing inwards, which is good. I want to have maybe 10, we'll try as our first instance. And I want to keep my edges sharp because I've got a planar surface down the bottom here. So if I round that off, I'm not going to be dealing with this planar edge when I get to the inside, and then we'll have a round and a planar, and that might cause problems when they interact with one another. Let's click enter to see how this one works. And we can see we end up with a pretty cool, almost kind of like a gobstopper with the top cut out. We've got a bit of a section profile here. You could imagine we might make this a different colored material to emphasize that slice going through. But most importantly, if we were to click on this one, go back to our details, we would see that, yes, it's valid polysurface and it's closed. Remember, that's the key word. We know that this is solid now, so we would be able to take this through to a 3D printer. Okay, well, let's say if we don't want to start our solid out of something primitive. So we don't want to start with a square or a sphere geometry. We want to start with some freeform curves like we've got here. So if we imagine an A4 piece of paper or a bed sheet that I've just scrunched up here, I've got these 4 freeform curves that I've made, which all touch each other at the corners. I've then jumped over to my front side view, and I've made this curve we see here, which kind of sweeps up and over. And you can see from this top point view that it kind of stays within the bounds of this edge and within the bounds of that edge. And then I've done the same thing over here on my right view, going in the opposite way, once again staying within the bounds of these edges. And if we jump over to our perspective view, we can see we end up with something kind of like this. So I'm imagining I'm going to get a surface that kind of flows over this shape here from these 4 points, but roughly up to this big mound that we've created in the middle and following along these curves. So rather than just jumping straight to some lofts, I'm going to show you another command that we can do to create some interesting shapes here. So if we jump up to our curve and then curve from 2 views, what I'm going to do is I'm going to go around this little set of curves, and it's going to ask me for 2 points. And you see it's created a new line here. This line is the balance of these two. So it's figured out if I were this line in space and this curve that we have down here, and I put those two together, what am I going to be? So I've got the balance of both of them. So I'll give you another example. I want this middle one here. If I press spacebar to repeat the move, middle one and N1 here, I've now got that object wrapping around there. And I'm going to do that for all of the sides. So again, spacebar to middle, and then one last side, spacebar to middle on this one here. So that's given me these kind of 4 curves, the average of both the X of Y and the Z curves I've got. Next thing I'm going to do is just delete all of my original curve set just to clean it up on the page a little bit. Now I'm going to make a surface with my edge curves that we have here, and then I'm going to delete those curves because they're just going to get in our way. So we've created a pretty interesting surface here just by creating averages of some curves. But now we want to turn it into a solid. So let's have a look at a few ways to make a solid out of something interesting like this. And we're going to start off by using the mirror command. So I'm going to go to my 4 views so I can see what I'm doing. Type in mirror. I want to mirror from this corner over here. And I want to mirror this way underneath. And I'm going to turn my ortho on so that I'm snapping its mirroring directly underneath itself. Okay, let's jump over to perspective to see what's happened. That's looking pretty cool. Kind of looks like top of a jumper or a shirt wrapping around a body, or maybe some medieval armor, something pretty interesting. I'm going to pull this down with my gumball just till I'm not quite touching so much anymore. See, these ones aren't touching, which is good. That's what I want. All right, so now I've got 2 halves of my solid. We need to fill in these gaps. Remembering back to our surface techniques, I'm going to use the Loft command. So I click Loft on the 2 sides that I want, press enter. Oop, we've got a mix up, but we remember how to fix that from last time. I go to Align Curves, click the corner, that's fixed it up nicely. Enter to finish. Oh, sorry, do that again. Loft, click, click, enter, Loft. There we go. Do the same thing on the other sides. So we've got Loft, click, click, enter, align those curves. Yes, please. Enter to finish and Loft. One more on this back. Do I want this side or this side? I want this side to be my top. It's kind of looking like a vase now, so I want that side to be the top. And I click spacebar to do it again. Loft, Loft, enter, Loft. That is looking pretty cool. Okay, let's rotate this so we can make it our vase shape. So we can see our gumballs going that way. I click on the red rotate axis, 90 degrees, and it's now sitting in the same direction as our construction plane. That's kind of awesome. From this angle, looks like a piece of A4 paper pushed together. From this angle, it kind of looks like a traditional vase. Pretty interesting in terms of a geometry. Let's have a look at a rendered version. That is pretty cool. Okay, so we've got some surfaces now. Go back to shaded so we can see what we're doing. Let's join these guys together. So we go over to join those together. Now we've got one open poly surface. So what does that mean? It's still open. We need to close that off so we can make it a solid. We want to 3D print this thing, right? So you might have guessed it. We're going to use that offset surface tool again. So we can see our normals, they're pointing in the right direction. They're going inside this. That's good. I want to be rounded this time because I've got a bit more of an organic freeform shape, so it's going to cause less of an issue. I think probably about 3 millimeters is enough. And yes, I want to delete the imports because I just want the bit left over. And yes, I want it to be solid, of course. Click enter to finish. Let Rhino do its calculations. Bada bing, bada boom. We have ourselves a closed poly surface. So now we have our closed off vase. And of course we could edit the thickness of this if we want it to be a bit thinner, if we want it to be thicker. We could have, if we had history turned on, we could have pulled around some of these shapes and edited the geometry, but I'm pretty happy with this for now. So you can see how we can turn some very, very, very organic forms that come from our freeform curve into a solid, rather than going through pure geometries. All right, let's now talk about edge analysis. So say for example, we're finished making some poly surfaces like these ones we have here. We join them all together and then it says something like one open poly surface. And we slap our palm to our head because we were really hoping this one was going to be solid so we could send it straight off to the 3D printer. Now, keen observers might have seen that I've created a little gap down here in the underside of the box. But sometimes it's not as obvious as that. Often everything will look perfect on screen, but no matter what you do, you try and join everything together, you can't see what the problem is and why it isn't becoming a solid. You go over to your details, it says that it's an open poly surface. Gah! All right, so here is a way to figure out the problem. So if we jump over to Analyze, Edge Tools, Show Edges, and we change this to Naked Edges, what it will do is show us exactly where the problem is. Naked edges means any edges on the surfaces that are not currently joined together with another edge. So basically pink is identifying where the gap is in our solid. So we know now where we need to plug the gap to fill this one in. Now there's a few ways to go about this. Of course I could just rotate this object back together. I could just put this surface back where it was. But a faster way to do that, and often will resolve a lot of your issues too, is by just making a new solid where those curves are, sorry, a new surface where those curves are, so that we know it's going to fill exactly where it needs to fill. So if I now join all of these together, I see one closed poly surface. I can go back into my Analyze Edge Tools, Show Edges, select this surface, and what do you know? There's no pink on here. Perfect. So I know now that this is an object that is solid and would work fine in our 3D printing, laser cutting, or CNCing. Let's say that we're not dealing with such a simple problem though as a planar curve. So if we're dealing with a spherical geometry like this, so let's first make a hole in this so that we can create the problem. So what we'll do is we'll do a trim command. We're going to use this curve that we've created here as our cutting object. We're going to cut inside this sphere and we can see we've created a hole there. Okay, jump back to perspective mode. Now, say for example, we wanted to create a planar curve out of this surface that we have here, the cutting surface, and we wanted to be able to glue this gap back together. Now, of course, we can try and just push this back in, but remember, we're dealing with a curved form now. We're not dealing with the same planar geometry as we were with that polygonal shape we had before. So we're going to have to do things a little differently. And there's a few ways that we can approach this. Personally, I prefer the blend surface command. So if we go to blend surface, I'm going to select this first edge that we need. And then we have our second edge. It's going to ask for the rotation, the seam point, and then we can see we have our options. And this is very much similar to what we were dealing before in our surfaces. So we can go from just position to position, straight out. We can take the tangency of one through to the other, and we end up with this kind of pretty cool handle. Take the tangency on the other side, makes it a little bit more ergonomic. And then of course we can go to curvature. and click OK for that one. So now we can see we have surface and a surface. What happens if we join these together? Two surfaces into one open polysurface. Bum. So it's still not the way we want it to be. It's still not solid. So let's have a look at what our problem is. So we go up into Analyze, Edge Tools, Show Edges, and we can see that this is the problem. So there's no problem where our surface met before. That's great. That's the hard part dealt with. Now it's just the planar element that we need to deal with. So we'll click on Done, get rid of that for now. Let's delete this guy, and what we're going to do is we're going to make a new surface edge out of this one here. So now if we double click on this edge, or if we go to Surface, Planar, click that edge, let's see if we can fix it with a new planar curve. Go together and join, and now voila, we have one closed poly surface. Again, we can double check Edge Tools, Show Edges. No pink. Perfect. Final check over in our Details tab. Closed, solid. Great. That's exactly the keywords we want to see for our 3D printing. All right, let's have a look at some of the incredibly powerful tools we have now that we're working with solids. So what I've got here is a bunch of different solids all working together. And effectively what I'm doing is I'm creating a tile. I'm going to play around with what we call a boolean to bring me different options or different variants, different iterations for that one tile. So I've got a solid surface here, which is a network surface with some lofted points to create effectively this block. We have a look at it in isolation here, there it is. And I've got a grid of these oval shapes that I've arrayed out together into a uniform grid. And we can see that they are intersecting down into this block that I've carved out from. All right, let's have a look at some of these solid tools. So if we go up to solid, the first one I want to talk about is difference. So it's going to ask us, what do we want to subtract from? And difference is effectively, we're going to take away one solid from another solid. So first, I want to try removing all of this grid of ovals from my block that I've made. So I want to subtract from my block, press enter. And then what are the things I want to subtract with? That's all of my ovals. So I'm going to come down here, select all of those, and press enter. It'll take a little while to calculate. And then we're left over with the difference between the two. So we've taken the ovals away from our block, and we end up with what might be some sort of textural acoustic panel. So really quite an interesting surface that would have been very, very difficult to draw. But because we can create the two different solids and then take one away from the other, we end up with something really quite sophisticated and interesting like this. So that's the difference. Now let's look at a few of the others. Let's look at Boolean union. So we'll go back up to solid. This time we'll click on union. And we're going to click everything this time. So let's just grab everything, click together. Now, what's Boolean union done? Everything looks pretty much the same to me, but let's go ahead and turn this into a wireframe. So we'll see as we now go down underneath our object, it's deleted everything where they overlapped. So this is really important for things like 3D printing. We don't want to make anything that we're not going to see. Now we'll talk later about scaffolding and making sure things don't fall over in your 3D printing, but we don't need to go into the intricacy of all of these perfect ovals on the inside of the block. So we can use union to join things together so that we know that we're only ever really printing that which we're going to see. So that's another really useful tool. Let's turn this back onto shaded, and I'll Command Z, Control Z. And I can see that they're now going all the way back down again. Let's have a look at another one. This one is intersection. So we go back up, solid, intersection, and then effectively intersection is the opposite of the union. So this time what we're going to do is we're going to keep everything where it touches only. Only where it touches is the part we're going to keep. So first set of surfaces are poly surfaces, we've got our block. Second set, we just grab everything else. Put it all together and we'll wait and see what happens. Now we can see only the parts where the surface was touching, so where these cylinders were inside the block, is left over. So this is, again, really, really powerful, and it's generated a field of objects that would have been very, very difficult to just create manually. All of these faces are talking to one another, so where the curvature of the surface was, the curvature is now mapped over the top of these faces. Now, yes, we could extrude to individual heights, but getting these faces to talk to each other so perfectly would be very, very difficult to do manually. So again, we can create something pretty powerful. We could then go and add another layer underneath this and then boolean those together so that we just have these elements sticking out of a tile, and then maybe that's a tile that we create for our assessment. But you can see how intersection works there. Last thing we want to do is to look at boolean to objects. So I'll just Control Z to bring that one back, and we jump up to boolean to objects. So click one object, second object, and we'll see that it says to click to iterate through boolean results. I'm just going to zoom down here so we can see what's going on. So we click through, so it's given us option 1, option 2, option 3. Okay, so effectively what it does is it shows us up front what our different options are in terms of an iterative development. So it gives us all of our intersection, our union, and our difference options all visually right there, so we can see what's going on. We'll escape out of that. So that's a helpful tool if you don't know which one you want to work with yet and you want to do some iterations. You might want to test all three. Now, of course, you could just make 3 copies of this, put them side by side for your assignment, and show us a few different options of your tile, whether or not we're doing the difference, the union, or the intersection. Or you could, if you want to just work fast and that's not really what your priority is yet, you could just do a test 2 just like that there. All right, now I want to talk about another really powerful solid editing tool, which is the wire cut. And wire cut acts exactly like you'd imagine your hot wire foam cutter cutting through foam. You put your piece of foam up against it and it carves a very smooth amount out. Or if you have a piece of wire and you're cutting through clay, it leaves a very smooth edge cutting through. And this is the same in Rhino. So typically when we do a split or a trim through a solid object, we then need to cover up the hole that we created. The wire cut is going to cut out of our solid and then close everything over after it's gone through. So let's have a look. What I want to do is I want to cut a channel going through there. So I've got this really organic form. Now I want to mix it up by making some rigid geometry going through it. So I come over to my front tab over here. I'm going to make a polyline, something that goes down. Let's turn my ortho on, down into the object, across, back up again, turn my smart track on, back up again, and close. Now I have a closed poly. All right, I'm just going to pull this guy away from the model just to make it a bit easier to see what I'm doing. Okay, so we go up to solid, solid edit tools, wire cut. Select your cutting curve. That's the polyline we just made. Things to cut, that's our piece of clay that we have here. And we press enter. Then it's going to ask us how far in do we want to cut. So I can see if I'm cutting, if I'm looking down here on the right angle, I'm just cutting part way into the model, or I can cut the full depth of the model. For now, I want to make a channel all the way through. So I'm going to click pass through the other side of the model. Then it's going to give us a preview of the part that we're cutting. Now we can invert that and just delete the whole model and keep that slither that we've cut, or we can just cut that part out. I think that's all I want to do. So, and we could also keep it as well if we want, but I'm going to delete it. So press enter to finish, and we can see that's carved a beautiful channel inside this tile that we've created. We could do that in multiple ways. We could even cut slices in this direction. Doesn't have to be rectilinear. We could cut any geometry out of this thing as well. So we could add even more curvature and slice it through as though we're passing some wire through clay. Really, really powerful tool. Now I want to talk about undercuts and undercut edges. So what I'm going to do to illustrate that is do a wire cut through this into about there, press enter. Now, this in making 3D printing Rhino circles is what's called an undercut. So we've got this lip that's running over and under here, and we've effectively got this cantilever of stuff that's going on there, and that's going to be really difficult to 3D print. It's also going to be really difficult to connect objects together. If you were doing any casting out of this, it's going to create a nightmare. It's not really good for anything. It doesn't really add a lot to our surface either when we end up with little bits like this. And the best thing to do in this situation is either a fillet or a chamfer. So let's have a look at how to do both quickly. So we go over to solid, fillet edge. Now I'm going to go fillet edge, and I just click around at the edges that I want to fillet. I'm going to do all of them so they all match up nicely. And if we zoom in now, we can see it's kind of rounded the edge for us off. And that's going to make it a lot easier to build because it's not an infinitely sharp point there. It's going off to a point inside there. And we can also experiment by playing with these little handles that we can see here. We can pull on the handles and make our points bigger or larger. So if I make that bigger, you'll see it'll upload and it'll go back there. But now it's too big and it's created a fault inside there. So we can bring that back down again to 1. We'll see what happens there. And there we are, we're back to it. I can make it a little bit smaller, a little bit tighter. And that's going to bring it closer to our original line there as well. And you can do that with all of your different points. And that's the fillet. All right, let's have a look instead at the chamfer. So I go back up to solid, fillet edge, chamfer edge, and then same process again. Click all of your edges, press enter. This time we can see instead of rounding it out, it's given us a cut. So it's created a new surface between this top surface and the inside surface that kind of blends the difference between the two without rounding it off. Now, typically it will start on rolling ball, and fillet might start on rolling ball as well. And often you'll end up with this error where you'll only see the final product. Preferably you're sitting on distance between rails, and that will usually fix the problem. And then once again, we can jump out here. We can play with our handles, make them a little smaller, a little bigger, get them to where you would want to be. And of course, you press enter, enter to finish, and that will give you your completed shape inside there with a lot more manageable surfaces. All right, that wraps up some of our solid tools, and of course there are plenty more you can play with in here, so I do recommend you jump in there and have an explore. Now let's talk about some of the things you need to know in terms of your workflow, in terms of how you go about doing what you do in creating your surfaces for your assignment. So I want to talk first about the basics, things like how to move, how to rotate, how to scale, how to duplicate, how to array, all of those very, very useful things that are going to make working much more efficient, much faster for you as you go. So let's go through the basics of each one. So to move, of course, we can just click on any object and we can just, if the gumball's turned off, we can just drag it anywhere we want. And in that plane, it's just going to move it for us. We can, of course, have the gumball turned on, and we can pull on any of our arms. We can go over to here and pull on the Z-axis and pull it up vertically as well. But these options really don't give us as much control as using the full command. So if instead we type in move, hit enter, it's going to ask us from what specific place do we want to move it from. So I've got center turned on, so I can come down into here and click in there, or I can hit end as well and find my midpoint. Now I'm going to be able to put it in a very, very specific location. So if I had another object out here that I wanted to join it to, let's say we have a basic cube which is sitting out here. There we are. Let's say I want to move from that center point. So if we go into there and click into that exact corner, we can do that using our snaps. We've got end and center turned on, and I can move it to specific locations. I can also, if I undo that, move by a very, very specific amount. So I can move from this point in space, and I can move by exactly an amount. Let's go by 100. I'll click there and I can see it's moved by exactly 100. So the shorthand for that, of course, as well, if we jump to our gumball, we've looked at this before in curves, but it's the same applies. If I click on any one of my arrows, I can move by specific amounts as well if I wanted to do that. So that's another option for you as well. All right, now let's have a look at the rotate options. Now, of course, on our gumball, we can grab and rotate. If we turn our ortho off, we can rotate by specific amounts. I can turn it in this direction, whatever direction I'm looking at, I can turn it in. I can also just click and rotate by an amount. Of course, this is a revolve shape, so you won't see it rotating. If I do it in the other direction, 90, and enter, there we go, we see that as a rotation as well. Again, we've got the long form way to do this too, so if we go rotate, it's going to ask for the center of rotation. So I'm going to come down here. This time I'm going to click, actually I want quadrants on the outside. Near and okay. So now I can get my quadrant here to the other side, and I can rotate around that specific point. I can also rotate in 3 dimensions. So I go rotate 3D instead. So now I can rotate by any axis. And this is actually even clearer on the cube. So let's do that on the cube instead. So rotate 3D. I want to rotate from this bottom corner, if we turn on end, up through the top corner. I want to rotate that way. So now if I click anywhere here, we'll see that I'm now rotating through that specific axis, right? So really quite powerful in terms of your rotation there. Another thing to mention while we are doing our moves and our rotates or anything like that, if we use Alt while we're doing that, say I hit Alt and then I click 90 degrees, it's going to make a copy while I do it. Or if I hold Alt while I'm grabbing and dragging, it's going to make a copy there as well. Or if I do move from point while I'm holding Alt, I can make that copy as well, as you see there. So that's our move and rotate options. Let's have a look at scale. Delete these. Okay, so to scale, of course, once again, we have our gumball. We can just pull on one direction if we only want to scale in the one direction. If we hold down Shift, it'll do all 3 directions at the same time. If we click, we can scale by a factor. So if I want to increase it by 50%, I'll do 1.5. We'll grow just that way. And the other way, I want to do it by 100%, I do 2. And we can see it's rotated in each specific axis one at a time. What if I wanted to be even more controlled than that? Now, I've got a few different options in my scale. I can scale, which is all 3 directions. I can scale 1D, which is just 1 dimension. And I can scale 2D inside there. And of course, I can make copies while I'm doing that as well. Let's have a look at a duplication. So you might want to create a copy of your object in the exact position that it's in. Command C, Command V. Click there again, and we can see there's 2 surfaces this time. So that's how we create a copy in the exact location that we want it to, which is different, of course, to if we go to transform and copy, it's going to copy from that one location outwards. It also gives you infinite copies rather than just one at a time. So you can just keep clicking forever and ever and ever, create as many salt and pepper shakers as you need to. But what happens if we want to have a little bit more control in our copying? So I'm just going to Command Z all of this and delete this one out here. So let's say we are going to copy again. So we go to transform, copy. Now I've got a few more options here. I can copy just in the vertical plane. So if I click on vertical, go to my point, I can see I can make vertical copies directly above this object now, which is really kind of handy as well, particularly when you've got lots of geometries going on and it's hard to get things to just go vertical. By clicking, you can just click on that vertical. All right, what else can we do through transform and copy? Let's click inside there, and I'm going to put my ortho on, and I'm going to go across by 50. What else can we do with our copy? Go back up to transform, copy, select our object. I want to do it from this midpoint. Got my ortho on out by 50. It's asking me which way we want to go. I want to go this way. I've got a few options here now. If I click from last point, instead of copying it from that original point, it means I can now make copies from the previous. If I then also go use last, it's going to do it by the same amount, by 50 again, by 50 again. And so I just keep clicking, and now what it's doing is it's creating a grid shape for me. I just keep clicking and clicking and clicking, and it's going to keep following that direction for me. If I click use last down here as well, it's going to take the last direction for me too, so that I don't need to use the direction either. Really, really quite powerful as a copy tool. Which brings us to our arrays, another type of copy. So let's come down to one salt and pepper shaker, and we'll come up to our top view. We go up to transform and array, which is this one here. We've got a few different options. First one I want to talk about is your rectangular array. We click our object, press enter, and it's going to ask us how many objects do we want in the X direction. Now I'm just going to do 10. How many in the Y? I'm going to do 10. I just want to do a 100 grid of salt and pepper shakers. And then how many in the Z direction? So I can also do a whole field of them as well. But for now, let's just put 1 in the Z direction. Then it's going to ask us to create a preview. So if I click on the center point out of there, and then I can hold my mouse around, and that's just going to help with visually seeing what the spacing is doing. So I want it to be in a rough grid formation like that. I click, and then this pink area that we have here is just a preview. So we can amend this spacing if we want to. If we want to get it a little tighter, we can bring that down to 30 by 30. Which we click inside there. And we can see that gets tighter. If we wanted to change the number, maybe we wanted 5 by 5 instead, we could do that. We've got a few different options there as well. And we click done to finish off that command. And we can see that's created a perfect grid of our salt and pepper shakers using the array tool, which is going to be very helpful for you when you start to create patterns and geometries for your surfaces. The array tool will be used quite a lot in your workflow. And there are other arrays there, of course. If we delete all except one of these, we can jump back up to transform and array. And we can see a polar array, a linear array. We can array along a curve, which is really quite interesting. Let's have a look at that one. So we go up here. Let's make a curve. Turn my ortho off for now. And I'm just going to do a curve like that. Okay, finish that one off. Now I'm going to move my salt and pepper shaker to start on that curve. So I'm just going to grab the base and go to the end point there of our curve. Okay, now we grab our salt and pepper shaker, go up to solid, array, where are you, array, transform array, and along curve, select my path curve. How many objects do we want? I want 10 along this curve. What happens if I have 10? Show me that. Ooh, that's kind of cool. Maybe I want 15. That looks pretty cool too. Or maybe instead of a number. I don't know how many I want, but I do know the distance between. I know the distance between is going to be exactly 40 millimeters between each one of these. So you tell me how many I need. It tells me I need 18, and I click done on that. So again, array is going to be really helpful for you because you might create some really interesting curves that you want to put a particular object on, and you want it to follow along that path so that you can start to create your interesting surfaces. Again, if we look up to transform here and array, we can see we can also array objects along a surface or along a curve on a surface. Again, have a play with those, see what you can come up with, experiment, and you'll find that you can make some pretty amazing things. All right, let's talk about another thing that's going to impact your workflow and make your life a bit easier. So you'll notice that when we're drawing, we're always drawing on this plane here, which is what we call the construction plane, and that is our sticky surface. If we to grab a freehand tool, it's always going to stick down to exactly that plane. So if we now rotate around that, we can see that it's stuck down onto that construction plane inside there. That's great for a lot of modeling, but sometimes we're working on surfaces that don't conform to the construction plane, something like this, which has a lot of different surfaces in many different angles and planes, and this is just not going to work for us. So what we need to do is change away from this world top view, which is the standard where it comes in at 0, 0, 0, and we're perpendicular to that Z axis. What we want to do is we go up to perspective, and we go to set C plane or set construction plane to object, and then I'm just going to click on the face that I want to work on. So if I now scroll around, zoom around, I can see that my construction plane is now set to that face. So if again I go up to my freeform curve, I can now create a curve on top of that face without any worries of it going somewhere else. Now, if I then try to move that curve, I can see my gumball is actually going in a different direction at the moment. That's because it's still conforming back to the world view, and that might be okay for you, but it also might be causing some dramas, because if I wanted to pull this curve off perpendicularly to the plane that it's on, the gumball isn't currently going in that direction. So here's what we do. This little white circle that we see just inside the gumball, we click on that, and we want to go align to construction plane. And we can see that it's now looking normal. We click on that curve again. It's now aligned exactly perpendicular to that construction plane. Once we finish working on our curves on that different specific plane, we want to jump back to where we were before. Very easy. We just go up to perspective, set construction plane, and world top. World top is, of course, where we do all of our drawing from the start. So we can just go back to there should we need to, and we can see that that curve is where it should have been. Just as an example, I'll again try and draw that freeform curve on top, and we'll see what happens to that curve. And certainly not on that face. We can see that, of course, because we're back on our sticky world top construction plane, it's now underneath the model, exactly where we don't want it to be. And it's completely warped out of proportion because it was drawing forwards, because we were drawing on an angle from perspective. So we can see there that we really do need to be able to move our construction plane to work in different angles. While we're working, it's also important to remember things like our ortho and our grid snap. If these are on, they can be very, very helpful, and it can make sure that we're going to very, very specific places. If we want to snap to the grid, that's great. If we didn't want to snap to the grid, or we've got a measurement that's outside the grid's spacing, then of course we need to turn the grid snap off while we're doing that. Likewise with ortho on or off as we're moving, if we don't have ortho on, what will happen is we can see ortho's on at the moment and we're going perfectly at right angles to where we started, which is good. Particularly in architecture and in modeling circumstances, we always want to be at right angles. It makes life easier to build later, even if we're dealing with curves and other geometries. If we turn ortho off, that's good because we might want to be able to move to a specific place. What we need to be aware of is whether or not it is turned on or off and in which situation. So always just keep in mind when you're doing your moves, when you're doing your transforms, is my ortho on, is my grid snap on? Because these are some of the things that will affect your ability down the line to make your model work. It'll also affect the efficacy of some of the tools inside this platform as well. Same as with your snap tools, of course. Now, speaking of snap, we do have quite a lot of power in our Rhino snap tools. So say, for example, we wanted to move our cube to be at the exact center point of any one of these circles that we have here. Sometimes you find that you do need to turn some of your snap tools off in order to get it where you want to. And I can see now it's going to the center with the end and near on or quadrant on. It might want to go there first before going to the center. So always be aware that your snaps might not be working correctly if you do have one on over the other. Of course, we've got Smart Track as well, so we can find the two centers of this point and then find a midpoint in between those two, which is very useful. We also have something that's called one shot. So let's start this move again. I want to go move. I want to find the midpoint, and I want to find the center of this box. Okay, that's good. Now I'm going to click on one shot, which we have here, and we see we've got a few more options in here now. I'll give you one example, and you can play with some others. I'm going to go between. Now, between is going to give me some points here. I've got a center point there. I've got a center point there. And we can see between has chucked my box right between those two center points. So now I know the exact middle of the bottom of my cube here is perfectly in between these two center points of these two circles. So one shot effectively expands your potential of what you can do with your snap tools. All right, the last thing I want to talk about in this video in terms of workflow is the planar toggle, which we have up here. I can see is currently turned off. So we've got the makings of a jug here, which we made by just revolving a section around an x-axis, or around the z-axis. And we're getting to the point where we would want to start creating a spout for this geometry. Now, of course, we've got some surface tools that we can work with, but in this particular case, I want to actually draw it in. I want to get specific about what's going on here. So what we would do is we'd go up to our curve, freeform curve, get the intersection, go out to the midpoint, start coming out here, and then back in. And we press enter to finish. We go and have a look at what we've done. Oh, and we can see that is definitely not the spout that we want to be drinking out of from this jug. So Control Z to undo that one there. And now let's try it with planar turned on. We go back to our freeform curve, out, middle, out, end, enter to finish, and we can see we have the makings of our spout there. So planar allows you to lock the plane that you're drawing in, and it kind of disables the stickiness of the construction plane momentarily for you. Another example, if we go onto the side here, so say if we've got that part of the spout, now we want to connect it back to the jug, we'll get another freeform curve. This time we want to lock out to our quadrant, back in, a little bit more, and then down onto our surface there. And then we finish, and we can see that that was locked in to that plane that we were working on the side as well. Now we'd be able to use some of our surface tools to create the surfaces required so we can start manipulating this jug so that it matches up with our spout. That's all for our solid tools and for all of our different workflow tools that we need to understand there. We've been through quite a lot today. We looked at all the different types of solids, from primitives through to creating our own solids, how to use the wire cutting tool, how to use the Boolean tools, which is going to create some pretty interesting stuff for your projects. And then, of course, some of your workflow things in terms of your move, your array, your copy. which will also become very, very handy for you in creating your own objects and surfaces. As usual, I want you to play around as much as you can. We didn't go through everything in Rhino today, of course. There are a million ways to do everything. So do go into Rhino, experiment, play around, start making some solids. Now, by this point, you really should be pushing into your assignment and developing some of your own surface treatments as well. The best place to start is doing exactly what we did in today's video. Start by messing around with a few different solids, cut away from them, cut into them, make some surfaces to map across the solid, erase some things over the top of the surface or around some curves. Do whatever you want to do. Just experiment and play for now, and then we can talk about bringing some of the research in and getting specific into the iteration coming up soon. In the next video, we are going to be looking at how to export from Rhino out to some 2D lines so that you can put it together for your draft presentation. We need to be able to take the lines that we have here in Rhino and take them into a package that we're more familiar with, something like AutoCAD or Revit or Adobe Illustrator, so that we can produce some slick looking drawings to go with our shiny screenshot perspectives. That's all for now. Have fun and enjoy.